Sure is. Look at that. Okay, and share screen. I'm going to go to desktop number 2. All right. Can you guys see? It looks like Rhino. And it looks like there's some crazy rainbow coloration on this thing, false color mapping sort of stuff. Yeah, the chat window disappears every time I share my screen. There we go. That's the most counterintuitive part of the interface for Zoom. I don't get it, but whatever. All right. They don't listen to me, that's for sure. All right. And why would they? They look at my emails and they go, who's this schmuck? Anyway, so the idea is we're going to start actually generating, axon drawings of your site and the surrounding context with some of this environmental information on it. And so this is obviously a different site, although it's downtown Las Vegas. I'm just going to quickly turn a few of these things off here. There we are. Yeah, all right. And yeah, that looks good. So one of the things you'll notice in my downtown model is I turned it so that the streets were going up, down, and left, right, so X and Y axes. So that means that north is actually sort of going in this direction, right? And so you'll see that I adjusted some things in my Grasshopper graph for Ladybug to make north, to sort of twist north a little bit, according to the angle of downtown city grid. If you didn't actually turn yours, and so your city grid is already sort of turned, so north is up, and when you look at the top view, that's perfectly fine. You don't have to do anything. We'll talk more about that in a minute, but I just wanted to point that out, right? So that's why this kind of looks a little goofy. The axis, the sort of east-west axis, is not a 30-30. It's actually much shallower of an angle than 30-30. So if you look at that and you're like, huh, what? It looks kind of weird, the arc through the sky. It's because it's not parallel with X or Y. I'm just going to delete a couple of other things. We don't have anything that we're actually measuring there. Okay. I'm just going to take all this out. Yeah, so they say we might get some thunderstorms in the afternoon places. That'd be really interesting. All right, so first and foremost, you'll see I just basically in my parallel view, right? So I went to set view and set this to isometric, right? So we get a paraline drawing. I don't know if it's northeast, probably southeast. We're probably looking northeast from the southeast. I don't know, maybe that's what that means. But I also have it set to rendered view. So it's just sort of in real time, just sort of rendering with the same settings that we had before, right? I'm just using draft quality. I'm not really going too far with this. Solid color of white, or I could say transparent background. I don't have my ground plane turned on. I have a street plane, but I don't want a ground plane on top of that. So I want this sort of looking like it's floating on a white table, so to say. I have a skylight set, but I have the sun turned off. So it's the previous renderings we did as underlays for your axon drawings. We turned the direct sun off. We just kept the skylight on, which sort of assumes on a day like today, of all days, right? We're talking about the sky vault and diffuse sky, right? There's still an abundance of light outside, right? Even though it's overcast. The reason I know that is because when I go outside, I can see things, right? Because that's how we see things. That's how we see color. It's how we depict objects. It's all about light bouncing off of them and back to our eyes. Certain parts of the spectrum of the light, or certain parts of the light spectrum bouncing back to our eyes, right? So there's actually skylight. What that does is that just sort of gets the diffuse light, right? So the stuff that's bouncing around in the atmosphere, it's not direct, it's not directional. That includes everything, all the light that we see that's, bouncing off of streets and grounds and the neighboring buildings and the mailboxes and everything else, right? Trees. And so we have that on. We can also turn on the sun. When we turn on the sun, we get a much more directional light, right? And that, of course, is based off of the position of the sun. And that, of course, is, I'm saying the position of the sun. It's really our position relative to the sun, right? As we understand. But basically is set by both our latitude and location on the globe, as well as the time of year and the time of day, right? So I'm in the render settings over here, so I have properties, layers, render settings. And I've just clicked on the sun. This is what mine looks like at the moment. I'm just going to click next to it where it says sun settings, and it gives me a box. Here I can also turn the sun on or off. Okay. It's going to tell me where the sun position is. Right now it says it's in the west southwest. It's really low in the sky, ridiculously low. In fact, you can see some pretty long shadows here as a result. And that's because it's telling me that it's in January 12th, or sorry, January 1st at noon. Or no, I don't know, maybe. But it's noon somewhere else. Like, I don't know where. There's local time, there's this time, right? So first and foremost, it looks like it's set for Accra, Ghana. I've never actually been to Ghana. That'd be kind of interesting. But what we can do is we can actually, down at the bottom here, search for our location, right? So it has most major metropolitan areas, including Las Vegas, right? That means our latitude is 36.175. Don't ask me what that boils down to in degrees, minutes, and seconds. And then, of course, the longitude. It also sets your time zone. So right now it's calling a specific time zone, same as Los Angeles, Seattle, Tijuana, Baja, etc. Yeah, so January 1st at noon. All right, so now I can also set my location here. And I can also set my time of year, right? So in this case, maybe I just want to go to June, right? 21st. Let's go with 2021. I guess there are slight differences in year, I suppose. Daylight savings time. Yeah, there's daylight savings at the moment. And let's go with sometime in the morning here. Yeah, 10 a.m. We're almost there. 9:54 is what this thing says. Interesting. Let's go with 9:50. Right. So what you can begin to see is you can actually start to track shadow information that your neighbors are casting on a site, and sort of see, in general, where you have shade, right? That's really important in an urban environment, of course. Okay. So if that's interest to you, right, to sort of turn on those sharper directional shadows of the sun, this is kind of how you do it, right? I can hit OK. Now when I render it, it's going to render the sun. I can turn that off again and just get the soft shadows. Okay, there's several different skylight options. Without that, it just looks kind of like a generic flat rendering. It's not so interesting. But I can turn on that skylight, right? I'll just leave the intensity as default. Turn on that sun. Let's see here. The intensity, if the sun's too bright, I can always turn it down a little bit. Depending on, if it's too washed out or you want to sort of see things a little better. Just leave that at 1. All right. So I just wanted to show you guys that. And now, for the time being, I'm actually going to go to shaded view. All right. So we just went over turning on shadows, right? And we could theoretically, pick certain times of the day and year, and then render out or capture that rendered view with the shadows to start talking about, how much shade is casted by neighbors throughout, particular times of the year. Yours, I'll say this: your site probably doesn't have so many shadows being cast by the neighbors, right? A lot of the neighbors are either across the street, they're lower lying, or if they're not on the same block like that pawn shop, they're pretty low lying buildings. It's not a particularly tall building, or they're far back, offset from the sort of public right of way is between us and them, like a sidewalk and a roadway, another sidewalk. And so, and then even I'm thinking of the tallest thing that's close to us, catty corner to the northeast, and then the parking garage to the north. Those aren't going to be casting too many shadows on us because they're to the north of us, right? So, but I just wanted to point that out, right? That's how you can begin to do that. And so another thing I wanted to do was then let's start mapping the sun position in the sky, because I think that's really handy sort of diagram to have. And the idea is we're going to generate a set of diagrams where we can start to diagnose up front some of the issues that we're going to have to contend with when it comes to sun, light, heat. Okay. And then what we can do is we can use those diagrams to sort of show the problem and also begin to delineate a set of sustainable strategies that we can use to address sun, light, heat. Okay. And so that's the goal for, a set of diagrams that we'll do. I'm going to go through this and do it for June 21st, right? We typically would do these for the summer solstice, the winter solstice, and the equinoxes. What I'm proposing is that we'll do 4 diagrams between now and Tuesday. Okay. But between now and tomorrow, we're just going to do June 21st. All right. And so more details on that as we go. All right. But so this is really important. I'm going to go through these motions, and I just advise you to watch. Okay. Make sure that things are making sense. If I skip something or I don't explain something very well, and you're like, how did you jump from here to here? I didn't understand that conceptually. What happened or what you just said? Stop me, all right? And I'm happy to explain it. Then we can always go back and just step by step push the right buttons, all right? But I want you guys to sort of understand what the process is, why we're doing it, and what the results are going to be. And then I can always go back and re-demonstrate. I'll also post this recording so you can go back and rewatch it for a little step-by-step minutia of, which menu, which button, which command I typed in for certain things. And, okay, so I do recommend just sort of sitting back and watching for the time being. All right, so this is my site. And what I'm going to do is I'm going to, you can see it's very similar to yours. I have buildings masked out. I have blocks just sort of slightly bumped up off the street. This is the proposed site for me. Let's say 1, 2, 3, 3 to 4, 3.5 or so lots or parcels, city parcels. And let me think here for just a second. What I want to do is I'm going to measure. Oh, sorry, I'm jumping the gun. So let's talk about this just for a moment. I'm going to go back to top view, right? And as I mentioned, right, north isn't quite up. North is actually sort of slanted at the top left. So, if I was sort of drawing an arrow, north arrow, it would be sort of, at an angle compared to this, all right? So if you've installed Honeybee or Ladybug or whatever, like the instructions, and it seemed to be working okay, the first thing I'm going to do is I'm going to type in Grasshopper as a command in the command line. So when I type in Grasshopper in the command line, hit enter, okay, it's going to bring up the Grasshopper plugin. It's a separate window that rides on top of Rhino here. And let's see here. Dun, dun, dun. There we go. I have enough plugins that it takes a little while for it to load because it's loading all these extra components here. All right. Now we're just going to barely scratch the surface of anything you can do with Grasshopper, which is sort of procedural parametric modeling, sort of visual scripting. There's a lot of stuff you can do here when it comes to sort of making your design scheme, your design model responsive and able to be adjusted with sliders and changing numbers or plugging in data to sort of help inform angles of things or opening sizes and things like that. So so we're not really going to touch on that at all today, of course, and we'll see if we get to any of this more advanced stuff when it comes to parametric modeling. I doubt we will, but you never know. But anyway, I just wanted to sort of bring this up, right? There's a set of tools along with these tabs. They're sort of organized with these tabs. You'll see that there's a Ladybug tab, a Honeybee tab now. That's good. Let's see, Ladybug. Yeah. All right. And so again, I'm in this Grasshopper window, right? Rhino is behind it. I'm going to go ahead and say File, Open Document. And I've now moved these onto my desktop on my Mac. They were actually on the Windows side of things, organized really well. I just forgot to look in the Windows hard drive the C:\\/ instead of the Mac OS hard drive, of course. And so I'm going to open up the SunPath file, which I think you'll find on the Canvas page. All right, when I open this up, it might pop up with yep. All right, so it's already popping up and asking me for a weather file. I'm going to hit cancel really quickly, and I'm just going to pan through here so you can sort of see what's going on here. Right, so false. I'm going to turn this to false and save it so that it doesn't continue to ask me for a weather file every time I turn this on. Okay. But what you can see here is that, you know, there's these nodes and then you're connecting them by rubber bands, right? So these nodes correspond to tools that you would typically find in Rhino, right? So something like make a polyline, right? So, you know, there's actually a node that's to make a polyline. In fact, here it is, right? So it says, okay, I need a polyline. What do you need? What ingredients do you need to make a polyline? I need a set of points, right? And so what we would do is instead of like clicking around and drawing stuff implicitly in Rhino modeling space, what we're doing is we're creating this sort of mind map of that process. And that way we can always change things later. We can go back here and start to, you know, sort of change things around. So I could basically create a list of points, plug that in, and it would create a polyline for me in Rhino, right? And so it's kind of like scripting, but without actually writing the scripts, like actually having to learn VB script or something, or trying to figure out how to do Python programming. So what you'll see here is a set of gates called toggles where you can toggle true or false, right? And then in some cases, you'll see some sliders that we can adjust. Those are parameters or variables, parameters that are variable, right? In other words, we can adjust them as we need to, right? There are a couple of widgets here where we input some geometry. And then there's some widgets where they, you know, generate, let's say, not only just the sun position, but then we populate it with a sphere of a certain size, or, you know, we want to see the path or the ray direction. So I've created a line so in order to sort of delineate that, right? On and on and on, right? Or compass curves, sun path curves. All right. So that's a long way of saying you don't really have to understand everything that's going on here at all, okay? However, one thing I'm going to do is I'm going to go to this over here. I'm just going to say true. And it's going to say, all right, you want a weather map? Find what region or municipality you want a weather map or weather file for. And so, you know, I think probably Las Vegas has one, National Weather Service, the airport, North Las Vegas has one at Nellis, right? But if you go to, yeah, DOE, so download from the Department of Energy, Las Vegas, McCarran International Airport weather data, and you download that, it's going to give you a zip file. There we go. And then you can open that zip file and you'll see several different types. I think what it wants is the EPW type. Okay. I can toggle that back to false now, right? So this very first, and you usually read these things like a book from left to right. Okay. So I toggled the first from false to true. And what that did is that told me, hey, you need to download a weather file. It pulled it up on my browser for me, which is kind of handy. Once I was downloaded that file, I can turn that back to false. Okay, now I'm going to move over to the right. So you can see there's a column of sort of grouped widgets here and a couple of comments, right? So here's where you open the weather file, right? Here's where you right click and set the geometries, right? Here's where you can adjust the time, hour, day, month. And then here's where you can adjust some of the size and scale parameters for the sort of representation of sun and sun path that it spits out at you, and compass that it spits out at you at the end, okay? All right, so this one right here that says right click and select multiple geometries. I'm just going to right click on that widget and it's going to pop up with a window. And I'm just going to go, or sorry, a set of options here. I'm just going to go to set multiple geometries. Okay. Now what I'm going to do, and here's what it's going to do, and I'm going to say set multiple geometries, and Grasshopper is then going to disappear, because that's what, when I say set multiple geometries, what I'm going to do is I want to select certain Rhino geometry, some of the model that I built in Rhino, and reference it into Grasshopper to use and build off of parametrically in Grasshopper. Okay, so I'm going to say set multiple geometries, and Grasshopper is going to disappear because it's saying, oh, okay, in Rhino, select all the objects that you want to reference. Okay, so I'm just going to select my entire site model and hit enter. Now, I only do this for this, right? For this, I'm only doing this so that I can look at all these geometries, and then it can sort of look at them cumulatively and find the centroid. And that's, we're going to basically center the sun, compass, and everything else around the center of this larger sort of context model. Okay, so that's all that did, right? It sort of finds all of these, finds a sort of box that contains them all, and then we take that box and we find its centroid, right? And then we use that as the center point for all of this sort of analysis that it spits back at us. Okay. All right. You can see that there's one other parameter over here called north. And in this case, I think north by default would be up. So let me just annotate this so you can see it, right? I think this is 0 degrees. So this would be 90 degrees. This would be 180, 270. And so if this is 22.5 degrees counterclockwise, then what we would do is we would just subtract 22.5 from 360, and we get 338.5 or something like that, right? And that's what I'm just going to use. I'm just going to quickly type that in. But does that sort of make sense as a logic, right? So what I might do is change the slider to this parameter. Just go ahead and clear that out. 338.5 or something like that. I'll just do that for the sake of this. All right. Okay. Now, I'm going to go ahead and toggle this one that says false, right? Where it says open the weather file from your computer. Just going to toggle that to true by double clicking on it. And it pops up with this this window. This is the window that popped up before, right? And it's going to say, okay, come on, please give me a weather file to use. I'm going to say, okay, that sounds good. So let me go to my downloads and find that weather file. Right, so that weather file is going to contain a good amount of information, including the location, latitude, and longitude of the weather station. And you can see, actually, I got my direction, my north direction wrong. I should have put this in. So north, I'm sort of tweaked this the other way. Maybe I just go with 22.5. Let's see what that looks like. There we go. Yeah, so that went counterclockwise. 22.5. There. I made that harder than it had to be, I guess. All right. Again, if north is still that y-axis in yours, like you didn't rotate your site model to be sort of following the x-y axis, then you don't have to worry about this. You can keep this at 0 and everything will be all Jake. All right. All right. So here's what it generates. Right. It generates a sun, and the path through the year. All of these curves, these arcs, represent a particular month. Right. Time of day. These are in hours going this direction. Right. And then we have the compass. All right. Let's talk a little bit now. I have the Rhino preview up alongside the Grasshopper folder here. Oh, and that's kind of weird. Look at that. Oh, I see. Our centroid is up above the map. I kind of want that down towards the ground. Oy. How would I do that? All right. So I'm going to fix this. I might just back up here. So you can see that basically, it found the centroid of all of these items at once. I'm just going to right click on this again and say set multiple geometries. This time I'm just going to select just this street plane. Yeah. And that should put that point right there on the, okay. So this is why I don't want you following along necessarily. I want to make sure that this is just sort of understandable, that you're in the moment here. All right. Okay, so you can see there's a couple of other parameters here. So one is the sun path scale, right? Let's say that this is, too small for our model, and so we can't even see half of it, or it's way too large, and we have a lot of extra space, right? We can fine tune this so that it sort of really gets in there, and there we go. Maybe something like that. That's not too bad right there. And of course, we can adjust the scale of the sun as well, like the sphere that we're using. Maybe here. All right. Last but not least, here, just zoom in here. You can see the time, right? So month, right now we have it set for June, the 6th month day. I'm just going to double click on here and say 21. Of course, we could always just move the slider. Right. Okay, so anyway, I'm just going to double click and type in 21 and hit enter, right? And then of course the hour, right? So here we can see it moving across. There it is rising. There we are. Now it's setting. Okay. All right. So is the scaling subjective? Yes. I mean, you don't want a sun that's like looks like it's ridiculous, right? This is just a diagram showing, the position of the sun in the sky, right? So I mean, if your sun was like this large, that would be counterproductive because it would be blocking the entire model. In fact, it would look like the sun turned into a red giant and suddenly swallowed the earth or something, right? So, again, if it's tiny like this, too tiny that you can't even see it, then again, I'd question how useful that is, right? So I'm just finding that sweet spot here. Sorry, let me turn the sound off of my phone. People keep texting me. It's annoying. All right. So let's talk about this just for a moment. Usually what we try to do is we try to is provide a sort of sampling of the data across this, right? So normally we would sort of want to understand like what this is like in the morning time, mid-morning, solar noon, mid-afternoon, afternoon, evening, right? To sort of understand where that sun is across the day in this case, right? Okay. So it's really important. What we're going to do is we're going to continue to adjust this time. And what we're going to do is each time we sort of identify, let's say, we could do 8, 10, 12. Yeah, why don't we do that? Well, no, maybe we do, I'm trying to think about this. Yeah, let's do 8 a.m., 10 a.m., 12, 2, 4, 6, or something like that. So two-hour increments across the day. Each time we're going to sort of bake or sort of freeze that information into the Rhino file. So then afterwards, we can turn off Grasshopper and do a make 2D with all of this stuff. Okay. I see a question. So I see that the area blocks are smaller than the area we have for our project. I'm sorry, I don't quite understand. This is not your site, so this is just something I had already. But I'm not sure. Like this, you have a model. We just saw them yesterday, right? So your model is going to be in here, right? So you'll have to adjust the compass to sort of go around your model, your city model. This is just, a part of the block that I was looking at, plus some of the adjacent blocks. Your what you modeled is actually larger, right? So, and that's fine. Yeah, exactly. Sorry. That's a good way of putting it. Yes, that is much clearer way of putting it. I'm sorry, I'm a little lost for words. Okay, I'm going to go ahead and turn this back to parallel. I've been moving my viewport around a bit as well. Look at it from the southeast. Here we go. Yeah, there we go. All right. So there's that 30-30 set. But now what I'm going to do is, so I said we're going to look at the sun at 8 a.m., 6 a.m., 8 a.m., 10 a.m., then noon, then 2 p.m., 4 p.m., 6 p.m. We could probably look at it at 8 p.m. In June, but in winter it's long set by then. So, all right. So let's take a look at this. Day 21st, month, June, hour. Just going to double click there. I'm going to say 6 a.m. There it is in the sky. All right. So watch carefully. I have this set for a time that I want to sort of get freeze this and sort of get an instance of it, right? And again, when I'm doing stuff in Grasshopper, as soon as I close Grasshopper, it all disappears, right? All this extra stuff that I was doing in Grasshopper, right? So at a certain point, when we want to actually get the results of the Grasshopper graph here, what we have to do is we have to bake those things back into Rhino, so we get static versions of them, okay? So over here at the very right-hand side, I've grouped these together with the purple box, and there's a comment saying right-click and bake, okay? And so this is, you can see when I select the widget turns green, and the actual preview in Rhino turns green as well, right? So you can see that this is the compass and the sun paths going through the sky, right? Okay, so I can take all those curves, and I can right-click, and I can say bake, and I can bake them on one of the layers that I have in Rhino, okay? All right, so in this case, I actually have a sun path layer, right? Because, this is like a cooking show, right? I mix everything together, I put it in the oven, but then I take the finished version out of the oven that I put in 50 minutes before, right? So sun path, right? I'll go ahead and hit OK and bake those into the sun path layer. Now when I turn off Grasshopper, you can see I still have those sun paths. They're on this sun path layer, right? So I have that version here. Just type in Grasshopper to bring it back up. Right, there we are. Okay, and this is, you can see, is the sun path, right? So you can see that there's a trajectory, a line going from the center of the sun to the center of the site, sort of showing the angle of the sunlight, solar rays. Okay, let me go ahead and right-click and bake that sun, and I have a layer called sun and rays already in Rhino, right? So part of this is just sort of thinking ahead and making a few new layers in your Rhino file, okay, for baking these things into. All right. Then finally, I have the spherical surface of the sun. And again, I can always go back. This is the radius, right? You can see that the radius is a setting here I can adjust if I need to. Once I have that sphere looking really, really awesome, I can right-click, look for bake, right? And I'll bake that on the suns and rays layer. All right, so now you can see, if I turn off Grasshopper, you can see that I have the 6 a.m. sun on June 21st and the sun ray direction, and I still have the sun path and compass for this particular site. Okay, excellent. All right, so let me, cooking channel meets HGT. Yeah, exactly. That's a good, that's funny. Yes, indeed. All right, so now I mentioned that we want to have several different times of the day, right? So this was 6 a.m. I'm going to go back over to the left-hand side. I'm going to double click and I'm going to say 8 a.m., right? Right, and of course the sun moves and the ray that it draws is also sort of adjusted, right? Okay, and so I'm going to go back to this sphere in this ray, right? So I'm just doing one at a time, ray, bake, and I'll put those on suns and rays. Same with the sphere, bake, suns and rays. Right? So here we have this sort of parametric mind map, right? I can adjust all of these parameters, all of these variables. Each time I want to sort of capture, let's see that sun at 8 a.m., at 10 a.m., at 12 p.m., right? I bake them back into Rhino, right? So adjust the parameters, and then I bake. And then I can readjust the parameters and bake again, right? So now you can see after I turn off Grasshopper, here in Rhino, I have the 6 a.m. sun, the 8 a.m. sun. Next is the 10 a.m. sun. Just double type in Grasshopper again. Change the time of day to 10. I guess this will be military time. So we'll go 12 and then 14, 16, 18. All right, so right click, bake. Make sure I select that layer that I want, suns and rays. Same with the sphere, bake. You can see that it, by default, it's picking sun path. I'm going to switch it to suns and rays. And the reason it's doing that, let me go ahead and finish that. I'll close this down. It's because sun path has a check on it. In Rhino, it's the active layer. So if I know I'm going to be baking a bunch of stuff in the suns and rays layer, maybe I'll check mark that and make that the active layer. So I don't have to keep like, I don't accidentally put this on the wrong layer when I'm baking things in Grasshopper. All right, so that's 10 a.m. Now I can go to 12 and bake it. Same with the spheres. All right. Come back over here. Oh, not 2 a.m. Sorry, 14. Duh. I'll try. Maybe maybe my brain will wake up hopefully soon. This is my brain on 1 cup of coffee. Maybe I need 2 in the morning. I don't know. All right, okay. Yeah. I'll go with 16. Now I'm getting the hang of it. All right. So there's 4 p.m. Work. All right. And let's go with 18, 6 p.m. Here we are. That's a nice sort of sample, right? Okay, I'm just going to turn off Grasshopper for the time being. I'll come back to it in a little bit. But now you can see that we have a lot of information in this, right? Now, again, these sun paths, right? Like for instance, this line right here, that's going to be the path on July 21st. And then the one next to it will be the path on May 21st, right? So we have other months of the year that we don't necessarily need if all we're talking about is June 21st, right? So with this sun path, the thing I might do, since we're just talking about June at this point, is I might go ahead and just take out these other parts of the sun path and just leave the sort of part that is talking about June. I'm just being very careful and selectively deleting everything except for the June sun path information. Just get rid of these. Those are the times of day mapped out over the year. Right. So now we're really just talking about June. Yeah. Yay. Okay. And again, we have north. We understand the cardinal directions relative to our city grid and our CAD space. All right. Now, we're not quite done yet. We have another file to run in Grasshopper called solar radiation. Now, one thing I'm going to do is I'm going to go ahead and save in Rhino. That's always important. I'm going to save. Now, type in Grasshopper and open that back up. I can save this the way it is, right? It's just going to change those parameters or save with these parameters on. But one of the things I'm going to do is I'm going to go back through and everywhere where I see true, I'm just going to double click and turn it back to false. And that way it won't lag when I open up the file first thing. It won't ask me for, let's say, a weather file until I toggle it back to true when I'm ready to do that, right? So I'm just going to go ahead and turn those back to false and save. Okay. Now it's saying, okay, well, we don't have a location anymore because it's set to false. It's not streaming that information from the weather file that we gave it before. Okay, and now over here where it says SunPath, that's the file that we have open, right? We can have multiple files open. Just gonna, you can see this is the only Grasshopper file that we have open in Grasshopper right now. I'm just gonna hit the X to close that out. Now we get a blank brand new Grasshopper canvas. I'm going to go to File, pull down, and open the next file that I talked about. It's somewhere on my desktop here. There we are. It's called Direct Radiation. Again, I posted this as well to Canvas. Sorry, simple words today. I can't even. And again, I forgot to turn certain things to true and false before I gave you this file, before I saved it last time. So it's asking for a weather file. I'm just going to hit cancel for a moment. We're going to take a look at this one as well. I'll turn this to false, turn this to false, turn this to false. You see there's multiple gates here. That comes in handy because sometimes when you try to adjust something up here, you don't want it to wait for it to constantly try to recalculate the entire simulation, right? As you try to move a slide bar across the, like, say, adjust the day or the time, right? And so you can basically fine tune all of these settings and then tell it to spend 3 minutes calculating, the solution for, how much solar radiation is hitting all of these nodes on the grid. And then what it does is basically, so anyway, let's talk about what it does. Right here, we turn it to true and we give it a weather file so that it understands exactly where we are. That weather file also has things like daylight hours, which talks about the amount of daylight we get over the course of a year. But it's more granular than that. So you get daylight hours for the average over months and days, right? So we can actually be more granular here in measuring, let's say, just a day or just an hour, right? Or a season, like the summertime, or an entire year, to sort of understand how much sun is actually hitting portions of our site or portions of a building or the street or whatever we're measuring, okay? What it does then is it calculates all those values. It finds the minimum and maximum, normalizes them so that the minimum is blue, the maximum is red. There's a spectrum of color, and then it generates a false color map, right, that we can, implies that as a mesh that we can render out, right, so that we can get a graphic representation of the data. So we can see where the extreme hotspots are, and we can see where the shadier or less hotspots are on a site, okay? So I'm not going to pretend that this is, well, you'll see. Let's go ahead and talk about this for a moment. So one of the things we're going to start with, and first of all, I think it's important to sort of understand what we're going to measure, right? For the time being, all we have is our sites. And what I'm going to do is I'm going to draw a ground plane, its own ground plane here that includes the site and also the sidewalk and the streets and some of the street corridor around it. Okay. So I want to know, like, if I not only like, which parts of my site might be in shade, which parts of my site doesn't get any shade. I also want to know, like, are the sidewalks going to be hot, right? Do I need to start thinking of some urban design moves, like, planting some trees, etc., right? So I can begin to sort of think about, the site holistically, right? And I could even, ideally think about this as part of a larger urban set of urban corridors, and actually set a good example for future development, right? And future beautification, street beautification projects. I think that's really important, right? I mean, there's the bottom line, and then there's making cities more livable. And I would argue that if you're just sort of thinking short term about, one-time expense of like building, right, then, it makes sense to sort of like think cookie cutter and plain Jane. But if you think over a sort of over time, and you think about the expenses of, contributing to making downtown urban cores several extra degrees warmer just from having lots of pavement and no shade, and you think about livability factors, and you think about loss of economic activity because nobody wants to live there because it's concrete and crap, then, it starts to add up, right? So if you think about this a little more holistically, right, I think there's a value proposition to be made to do things smarter, to do things better, right? And to think about how to think about a person on the sidewalk, right? To think about somebody crossing the street, to think about, these sorts of things, right? Sunshades on your facade cost more money in a one-time cost. But if it cuts down your air conditioning bill over the next 40 years, right, then again, there's probably a value proposition, right? There's a return on the investment at some point, right? So to me, it's thinking a little further, right? I think trying to be better stewards of the built environment and our natural environment around us, to and better steward of our resources, right? Oftentimes I would say there's where there's an ecological argument to make, there's also an economic argument to make, but it's an economic argument that probably was never made in the 20th century when we did a lot of these things, right? And so we're starting to rethink a lot of these things as we start to see the repercussions of short-term thinking. So anyway, long story short, what I'm going to do is I'm just going to add a planar surface here. I'm going to pop it up so it's just sitting right above our site. Now, that's just going to be the thing that we actually measure solar radiation on, okay? So I'm just going to identify that as the thing to measure. And then what we're going to do is we're also going to tell it and give it all the buildings around, right? As stuff that can actually occlude sunlight, right? In other words, it actually be casting shadows. And then it'll do all of the analysis for us based off of the historical precedents of all the weather data that's been collected for this location, right? Or at least generically the valley over time. All right, so there's several things to do here. Okay, but again, I'm just going to go to the left, right? And if I need to, I can turn the very far left thing back to true. And if I was doing this one first, then maybe I need to download the weather file. This is going to give you the weather file again. I think, yeah, it's going to say, okay, download a weather file. Here you go. I'm just going to close that browser. Turn that back to false. I already have my weather file. I did that the last time, right? Okay, so I'm going to go to the next steps here. Now, as soon as I turn this on, it's going to start looking at a weather file. It's going to spit in the weather file, start doing some things with it, starting to aggregate the information into all these different outputs that we're going to use later on and spit into the sky matrix and all that stuff. All right. Having to do with radiation, illuminance, and temperature, humidity, speed, wind speed, wind direction. All right, so select the test ground surface, select the building context or building masses context. So again, this is what we're going to test, right? We could actually put in a building if we wanted to and sort of see, okay, where are we going to get the most solar radiation on our building? In this case, we don't have that yet. So I just want to measure the site. What this does is this starts to give us maybe insight to useful strategies or thinking about, what are going to be the challenges here on this site, right? And then we turn a corner and we start thinking about, okay, so how do we address those challenges? All right, so that's the goal with this diagram, this analysis. We're going to look at the sun position, and we're also going to have the solar radiation mapped onto the ground. And we're going to do that for June 21st tonight. And then over the weekend, you can also do September 21st and December 21st, and then a whole cumulative year, okay? All right, so. And again, we'll talk about those. We'll talk about those things further tomorrow morning. So I won't just this isn't the last time we're going to talk about this, but I just want to show you step by step how to work this thing. All right. So again, with this widget, it's orange. And there's a comment here that says select the test ground surface. All right. So I mentioned before, I'm just going to go to the top view that I'm going to just make my own sort of test surface here. I'm just going to go to my surface tools and use this rectangular plane corner to corner. I'm just going to draw a surface. Maybe I'll just draw across the entire thing here. There it is. Okay. Now it's actually underneath the curb information. I'm just going to lift that up, right? The curbs aren't going to be casting so many shadows that we really need to worry about them. I wouldn't think anyway. So I'm just going to make sure my ortho is turned on. I'm just going to lift this up. I'm just going to eyeball it here. Make sure that it's up above the sort of block curbs. Okay. All right. Okay. You'll find oftentimes when it comes to these sort of simulations, right, we have to be really careful. Garbage in, garbage out. And so what we do is we're really careful about, in particular, and clear about what we're trying to measure, what the limitations are, right? And being careful to sort of differentiate, I guess, what empirical data we can actually use, right? So it might not be that I would, once I start getting the metrics, I would say, okay, for sure, this is always going to get 6 kilowatt hours per year of solar radiation. But what I can say is that the red areas will get it probably 2 to 3 times as much information as the blue areas, right? So again, it's all about sort of making assumptions that add up, right? But we'll talk about that in a little bit. So I'm going to go ahead and go back to Grasshopper, set 1 brep, right? That's just a fancy word for surface or polysurface. I'm just going to select that surface that I had before. All right. Now select the context or building masses. I'm going to right click and set multiple breps. Grasshopper disappears. It lets me select all of these buildings. Wow, look at that. All right. I'm just going to tilt this up so we can, in fact, you know what I can do? I can just go to the buildings layer. And I can just right click and say, select all the objects on the buildings layer. That's easier, right? So in layers, I want to select everything on the buildings layer. I just right click on that layer and say, select the objects on that layer. Hit enter. All right. Okay, we're almost done. We have a few things to do here. Okay. One is we're going to turn this to true, and it's going to ask us for our weather data. All right. Okay, there we are. All right, now you can see that where this widget was orange, saying that there wasn't any data being fed to it. Now it's gray and it's happier. Okay. We still need to toggle this to true, but before we do that, I'm going to set these parameters, right? So here's where we can set a start time and an end time to measure from and to, okay? So from, this is where, again, we're just going to pick one day, right? June 6th. So month 6, day 21st, hour 1, sure. All right. And then month, I'm just going to say the same day, or same month, same day. So 6/21st, but then I'm going to go to 24, right? So here we start at the very beginning, early in the morning. Here we end at midnight. Okay. Again, we want to make sure that we have our north set the same way. I'll just say 22.5. All right. Now there's a couple of other, these are really important, okay? This is probably set to like just a quarter of a unit distance from the base. Just leave that probably. But the grid size is everything. So we take this large area, right? Now it's asking, okay, I'm gonna break up this area into a grid. What size of cell do I use in order to sort of break this up into a grid? The more cells we have, the more data it has to crunch, okay? And if you think about, an area like this, more cells in this way, more cells in this way, those start to, you basically multiply them in order to get the area, the number of cells cumulatively. Once you start to increase the number of cells in both directions, the amount of information that it needs to crunch and then map onto the site really starts to add up. I mean, it starts to get quite large and quite heavy, right? What I would recommend doing, and so grid size, what I'm going to do is I'm going to change that. I'm going to up that to maybe 5, right? So in other words, the cells are going to be 5-foot increments, not 1-foot increments, right? 1-foot increments would give us 5 times the amount of information in the Y direction, 5 times the amount of information in the X direction, 25 times the amount of information. So exponentially, the amount of information that we would need grows. So I'm going to start with 5. I can always make it more granular or less granular if it's taking an incredibly long time. But before I start to turn these to true, I'm just going to save all these settings that I've done. Let's go ahead and save. Hit that little save icon. Okay, and I'm going to go true over here. You'll see radiance is going to pop up, and it's going to start to use the weather data information in order to generate the sky matrix. Then it also then takes just the portion of the sky matrix, right? That sky data for just the minimum maximum here. So just the time period delineated here in Grasshopper. I'm not sure why Grasshopper disappeared. It's still there. I just minimized, maximized Rhino. It's still here. For some reason, it does that sometimes in Rhino 7. I'm not sure why. Okay, and then once we're ready, it's actually going to do the calculation, right? So here's where we spit in the geometry we're measuring, the context geometry that casts shadows, the grid size, all of that stuff, right? And here's the selected sky matrix that's going to spit out a mesh at us. So I'm going to go ahead and save one more time and hit true. All right, and this might take a minute or two, right? This is a large area that I'm calculating here. So 5-foot increments. It might take a little bit of time to calculate. So we'll just let it go. And I will say, the first couple of times you try this, it might be really frustrating because you turn this to true, and then it sits there and thinks for a long time. And you're like, is it doing anything? Did I mess something up? And you'll never know until it's done, right? So this is still being unresponsive because it's calculating a lot of information, a lot of data that gets basically then not only measured and organized, but then actually organized by color and then mapped back onto the site. So it looks like maybe it's starting to respond a little more. Still says not responding, but we're getting there. Let's see. Okay. And again, I'm measuring quite a large area here, right? So maybe I should have set the grid size to like 10 instead of 5 or something like that. And so when I started to minimize, maximize things, you can see that it's slowly doing those, but like there's quite a bit of a lag here. So now my Rhino is minimized. That was a dumb thing for me to do. I should just took my cursor. Sometimes I get antsy and I start like, trying to do things to see if my computer is really unresponsive or not. Mac is doing okay, the Mac operating system. Windows is still thinking pretty heavy here. Although the blue wheel's gone, but this is saying not responding. All right, so there's two things. Maybe I would argue you're not going to actually measure that large of an area, okay? But I could either trim down the amount of area that that surface that I drew, that gray surface, the amount of area that I'm trying to measure, or I could adjust the grid size, right? So I can make a larger grid size, which then gives me less information, right? So, it's always about finding a sweet spot between how much information you need and how feasible it is for your laptop to, I can hear my processor fan. It's kicked into high gear. I don't feel the temperature rising into my office here in the house yet, but it's, maybe it's done. Okay, well, there we go. All right. Okay, and so I don't think you'll see a lot of surprises here. What I'm going to do is I'm going to take this, I'm just going to take that gray surface, I'm going to hide it. You can see, right? My site's really hot, right? And, the streets are mostly going to be as well. Although, along this sidewalk, it looks like it's blocking a lot of west light, maybe a little bit of southwest light, right? You can see how courtyards work, right? Those can start to provide decent shade, right, in this area, depending on their proportions, right? But I don't see any surprises here, right? For the most part, this site is an unmitigated solar mess, right? And that's not, you can see where this building casts some shadows when the sun's in the east, right, over just that June 21st. You can see where this finally starts to cast some shadows, right? Once the sun is a little bit in the west, although it's still up pretty high, right? So you got to wait till looks like maybe 4 p.m. or so before you start to get a little bit of shade along the east side of buildings. There's not so much shade to the north either, right? Because in June 21st, the sun is so high up in the sky, right, that the shadows are very short, unlike when in the winter, when the sun is very low in the sky. But now essentially, we have, I think, the information that we need. What I'm going to do, last but not least, once this has generated something that we see that we like, is I'm just going to right-click this last widget on the right, this geometry. I'm going to bake that into Rhino as well. So right-click, bake. And I will just call this color map analysis, right? I just had a, again, I've done this several times with this example file. So I'm going to put that on the color map analysis layer. Okay. And that way, when I close this out, let's see what happens when I close Grasshopper here. I should toggle this back to false. You can see that I have, you know, actually turn this on here. Not sure what's going on. Color map analysis. Okay, turn this to rendered. You can see that the rendering actually uses the coloration that's mapped onto the mesh. Okay. So that's important to remember. Turn this back to, sorry, now my computer's being all slow on me. A little bit of memory. It's because, you know, I still have Grasshopper running in the background. So I still have that file. That, and I think my configuration with Parallels and Mac OS, I think I have a, Windows has a memory leak somewhere. It's really, gets bogged down when I do something too big here. And then when I restart it, it all speeds up again. So I'm just going to go ahead and toggle that back to false, right? And go back through and toggle these back to false now that I've generated this solution and I've baked it into Rhino. You know, I don't necessarily need all of these again. I'm going to go ahead and toggle this to false sometime today. This is taking forever. Oh no. Okay. So again, try to be patient, right? Let's see. Where'd Grasshopper go? Come on now. Oh, apparently I accidentally selected and dragged the building across my screen. Yeah, okay. Yeah, sorry, this is my, I'm just hitting escape here, trying to get this to respond a little better. All right, toggle that to false. Once I do that and I close Grasshopper, this should start to speed up a bit here, but just a lot of stuff it was trying to calculate and keep in mind at the same time here. False. And I'll save. And then I can turn off Grasshopper. I could turn off this file first, close that out, and then I can turn that off. I'm just going to undo accidentally moving that building here. Come on. I'm not sure what's going on here. La, 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 la. There we go. Undo dragging that across by accident. Again, I'm just going to save this. 20 megabytes. It's not that heavy of a file at all, so it shouldn't be. I don't know why it's bogging down, except some major memory stuff. What if it's still raining outside? I have such a short attention span sometimes.
Same.
Yeah, especially when there's actually like weather, you know. Anyway. All right. Okay. So, let's see. What else am I missing here? Am I missing anything else? I just wanted to, again, make this responsive. For whatever reason, it's not being so responsive. So at this point, then I would be really careful. I would make sure that this is set back to isometric view. Since I've been sort of rotating the view around and things like that, I just want to make sure this is set to an actual southeast 30-30 isometric here. There we go. Right, that's most of the information I need for, let's say, June 21st. Oop, I have one little stray path information path there. All right. And so what I'd like for you to do is try this on your own between now and tomorrow morning. Okay. And I'm fully expecting there to be some issues that we have to troubleshoot. Okay. But try to keep in mind, I mean, I hope like maybe conceptually you sort of understand what's going on here. So I will mention one thing, that there's a lot of one trap to fall into, right? And that is when you model this surface, wherever you're modeling, the surface that you're using to sort of measure to create this sort of color map analysis. Let me just turn this back to rendered and see what it looks like here. Right? It might not look correct. It might all be like blue, right? In which case something's messed up. And here I'll tell you what the common problem with that is. So there's a way to overcome that. And again, we can always go over this tomorrow if you guys run into problems. I'm just trying to locate my cursor. There it is. Yeah, Rhino and Windows are just really, oof. All right. I'm just going to make a new surface here. And I'll show you what happens, right? So this is a step you can perform before you run the solar analysis, the solar radiation, right? I don't know why this is taking so long. Come on. Come on now. All right. First corner. All right. I'm just waiting. What is this? Third corner of surface. What? Let's see. Sorry. There we go. There's a surface, right? I'm just going to turn this back to shaded. I might just need to restart Rhino here, but one of the things you can do is, like, let's say this is the surface I'm going to, measure, right? Like this surface over here. I'm just building this over here so you can see it a little easier. I can go to Analyze, pull down, and Direction. Okay. And what you'll find is that a surface, and particularly when a surface is turned into a mesh, in order to do this analysis, you'll find that the surface has a top and a bottom. And if the bottom is the thing that's actually showing on top, then you'll actually get, like, it'll measure the top, but then you'll get this sort of blue stuff on the bottom. And so what you're going to do is you're going to make sure that the arrows are actually pointed upwards, right? That's talking about the top of the surface. And if for some reason they look like they're down, then what you can do is you can hit flip, right? So that they're pointed upwards. And then that'll actually allow you to sort of map and get the map data correctly. Okay, so now I went to Analyze, Direction, then I selected that surface, and I looked at, is it up? It's pointed upwards or downwards, upside down. So it's right side up. I'm good. Like now, if it looked like this, that means it's upside down. I can hit flip and make sure those arrows are up or out, right? And then hit enter. So there might be some snags that you run into. Typically, it's either that or just it's taken an incredibly long time to generate because you have so much information that's trying to generate. So it's usually the granularity of how much you're measuring. Okay, all right. For your sites specifically, I'm going to go ahead and save and close. And while that's going on, let me bring up Chrome here. MAPE? How about maps? There we are. That works better. Let's talk a little bit about what you folks want to measure here. So if I was, sorry, let me get Rhino closing. Let me blow this up bigger so you can see a little easier. All right. There's Easy Pawn. That's always the telltale, isn't it? Let me get my annotate, my drawing tools here. Let me make a bright red. So I'm assuming this is your site right here, right? Plus that. And you have the sidewalk, street. What I would do is I would measure an area like this. Draw a planar rectangular surface that does something like that, right? So you're getting this street corridor. You're understanding any effects that sorry, excuse me, that the parking garage has, that this corner has, that this neighbor has, and you can start to understand not just this area, but also the sidewalk and street, right? The plots next door. Okay, start to understand where there might be a lot of heat. underside. And there's going to be a lot, right? I mean, this must have been taken when, I mean, that's a fairly noonish shadow right there. And it's fairly deep. So, I mean, I'm guessing that was taken late autumn or winter or early spring, just because of the amount of shadow we're getting there, right, at noon. So, but I wouldn't expect this to cast too much shadow, you know, when we actually want shade during the summertime, right? This is just so, I mean, it's not like this is 18 stories tall or anything, right? Okay, but did that make sense? So I'm sort of looking at, again, let me just beef that up here. Somewhere in this sort of neighborhood, right? When you're drawing that sort of plane, so that, you know, think about this as the sort of plane that you're measuring on, and this will be colored with a sort of grid of coloration when you're after you run the the uh, the simulation. Okay. All right. Just trying to make that easier to see. Okay. Are there any quick questions? I'm going to go ahead and stop sharing for a moment. Okay, I'm going to stop